So when people are introduced to complex numbers for the first time, it's usually kind of introduced like this. When you're finding the roots of an equation, or in other words, when this is equal to 0, let's say you want to find when y is equal to 0, what's x going to be equal to? Well, when you graph it out, you can clearly see that when y is 0, which is along this line here, then x is going to be either minus 1 or positive 1, and then you sub in here. If you sub in minus 1 or positive 1, you'll get both of them give you 1. When you square them, take away 1, you get 0. It's all good. Then a problem arises when you have the function y equals x squared plus 1. You can see on the graph it crosses nowhere on the when y is equal to 0. And the reason for that is because if you set y is equal to 0, then what happens is you get y equals 0, which is equal to x squared plus 1. Or in other words, x squared is equal to minus 1, equal to minus 1. Which means that x is equal to plus or minus the square root of minus 1. And then people are like, what is the square root of minus 1? Well, we're going to call that I, and that's what the square root of minus 1 is. And then after they've been introduced to that, they're like, right, how do we graph I? Well, we take the number line here. I'm going to move it down a bit. We take the number line, and we add in a new axis. And then we make that the y-axis, and we make that with the i's. So we have that this is equal to, we'll put I up here, we'll put 2i up here, and we'll put negative I here, and we'll put negative 2i here. But it's kind of you're kind of expected to just take a lot for granted. Like, well, first of all, why the hell are we graphing I here? And second of all, why is I the special number that we put on the y-axis? Why isn't it something else? Like, we have other problems we can't solve in maths. The square root of minus 1 is just one of them. For example, another problem that we can't solve in maths is the problem with infinity, and how do we not know that maybe we should graph infinity on the y-axis, since this is another problem that we don't know how to solve? So this could be infinity, and this could be to infinity, or something like that. And then that solves that problem. Why the hell did we choose I? Or furthermore, why do we choose the square root of minus 1 to be I? Why don't we choose, for example, if we have the equation x cubed is equal to 1, or x cubed is equal to minus 1, then obviously the fundamental theorem of algebra tells us that there should be 3 solutions, but you can only have one solution. The solution for this is 1, and the other solution is and the solution for this one, sorry, is minus 1. Why? But what about the other 2 solutions? Why don't we call the other 2 solutions I and minus I? And why don't we graph them then? Why did we choose the square root of minus 1 to be I and not the solutions for this equation? Well, I'm going to answer that question in another video because that's actually quite complicated. But for now, I'm going to show why it makes sense that we graph I on the y-axis, sorry. And then in the next video, I'm going to show why we didn't use this. Why we didn't use the solutions to these equations, and why we did use the solution to x squared equals minus 1. So why does it make sense to put I on the y-axis? That's the question. To understand that, I'm going to get rid of the imaginary axis first. I'm going to get rid of that. And we're just going to look at the number line. And when we look at addition, it's not very interesting. If we have, for example, 1, and then we add 2 to it, we just hop 2 to the right. It's not super interesting. You're just kind of going forwards or backwards. That doesn't tell us anything about if there was an axis here. It doesn't say anything about that. We're just jumping forwards or backwards. If we add 2, we'd go 1, 2. Or if we subtracted 2, we'd just go the other way. We'd go 1, 2. So addition and subtraction aren't very helpful, but what about multiplication? So if you multiply by a positive number, it just makes it longer. For example, if we had 1 and we multiplied it by 3, we get over here. Then we multiply that by 2, we get all the way over here. It just keeps going in the same direction. But then if we look at multiplication by a negative number, it actually becomes very interesting. And we're just going to worry about the numbers 1 for now, just because I think they're the kind of most easy ones to work with. If we just worry about the number 1, and let's say we start at 1. What happens when we multiply by minus 1? Again, we're just choosing 1 because it's the easiest number. If we do 2 and stuff, it's the same deal. It's just bigger numbers. So we're just going to choose 1. If we multiply by minus 1, what happens is we hop over here. And if we multiply by minus 1 again, we hop over here. And if we multiply by minus 1 again, we hop over here. You can see that it's kind of actually rotating. So when we multiply by minus 1, it does a 180 degrees counterclockwise rotation. It's 180 degrees. And then if we do it again, it does another 180 degrees rotation. You might be like, okay, yeah. What does that have to do with I, though? Well, remember that I is the square root of minus 1. It's kind of like in between minus 1. So when we multiply by I, when we multiply by minus 1, we get obviously a 180 degree rotation. Now, when we multiply by I, we don't know what happens. Let's say we take 1 and we multiply it by I. We don't know what happens. We just get I, question mark. But then let's multiply this answer again, and then we'll get I squared, which is equal to minus 1. So we know that when we multiply by I twice, that's a 180 degree rotation. So logically, when you multiply by I once, what do you think should happen? Well, if multiplying by I twice is a 180 degree rotation, then multiplying by I once must be a 90 degree rotation, which means that I should be here, because the distance hasn't changed. Remember, when we were multiplying by minus 1, we stayed at 1. We were still 1 unit on this direction, then 1 unit in this direction. So if we multiply by I, that's a 90 degree rotation, and we're still 1 unit, but in this direction. Then we multiply by I again, and the rules are satisfied. So if we start at 1, multiply by I, we get 90 degrees. Do it again, we go to minus 1. Perfect. Then if we multiply by 1 more time, what should happen next, logically? You should end up down here. You should do another 90 degree rotation and end up down here at minus I. Sorry, I drew that too far down. It should be here, because they're all the same number of units. So we multiply by I again, we should end up with another 90 degree rotation, which gives us not minus I, and we can verify this algebraically too. If we multiply minus 1 by I, we'll get minus I. And then finally, if we multiply by I one more time, it's another 90 degree counterclockwise rotation. You'd expect to be here, and sure enough, if you multiply minus I by I, we'll have minus I times I, which will do minus I squared. And remember, I squared, that's the definition of it. I squared is equal to negative 1. That's what we define it as. Here I just had it as x because we were talking about equations. So what we get is minus 1, which brings us back to 1. So that's kind of the first intuition as to why graphing, I suppose, complex numbers on the coordinate plane makes sense when you look at rotations. But there's another way to think about it and the reason why it works. And I'm going to show that in the next video because I don't want them to be too long. So this is kind of part 1, if you will.